Okay, morning everyone. Nice to have you here. Hope you all got here okay this morning, and it's a pleasure for us to be here at the NFPC presenting to you as well. I'm Victoria Parrott. I'm a business developer for Shell Panolin, which is their range of biodegradable lubricants, so hydraulics, greases, gear oils. We'll have a look at the portfolio a bit later on. I'm very kindly joined today by Tony, who is our technical advisor for biodegradables, but he's been in the industry for an incredibly long time and he's got a plethora of knowledge in there. So we'll tap into that a bit today too, which will be really good. Also, can I just ask, if you think of questions, please do ask them, but can we leave them till the end, if that's okay? Thank you. So today we'll look a little bit about market insights, what's growing, the demand for biodegradables, a bit about biodegradable itself, what does that mean, some of the technical elements to it, the portfolio that we have in Shell, some of the specifications and benefits that go along with it. And then finally we'll look at where those are used, because they're used in a range of sectors and regions and applications even within the sectors. So we'll show you that today, and then any questions at the end, we'll get there then. So in terms of market highlights, the annual market growth rates for biodegradable lubricants can range between 4.7 to 14% between 2025 and 2032. That could change. There are numerous reasons for the growth drivers of biodegradable lubricants, and that can come from legislation or regulation. Again, I'll show you that a bit later on, but there is loads of them. And so it just depends if any of those get expanded to regions encompassing like the UK, or even any new ones for the UK as well. Also things like OEMs driving for more certifications and performance characteristics, and some of the products that you'll see later on too have really good longevity, which is something that also OEMs are looking for at the moment in terms of their technological advancements. But in terms of the opportunities, it's a positive outlook for the UK biolubricants. We're seeing more and more regulations and shifting environmental standards. You've also got things like sustainability goals and agendas for the big corporate companies, but equally the social impact, people are talking about it more and what that might then do in the future. But there are some challenges in the biodegradable industry, and one of those is something that I hope will kind of myth bust for you today. And that is the misconception that biodegradable lubricants are underperforming, which is not true. There are a whole host of different kinds of base stocks for biodegradable lubricants that can influence the characteristics and performance of them. So we'll talk about that more, and hopefully you'll learn something there. Biodegradable lubricants do command a considerable price premium, but with the longevity that some of them can offer, we can also see total cost of ownership associated with that too. And then also the lack of awareness and adoption of biodegradables, but we'll see that come more and more, I'm sure, in the future, and hopefully today you guys can gain a bit of knowledge too about biodegradables. Let's get into it. So what are biodegradable lubricants? There's a lot of terminology in the industry for biodegradables. So the key ones that we'll talk about today are readily biodegradable or biodegradability, also ecotoxicity, so low or minimally ecotoxic products, or non-bioaccumulation. But what does readily biodegradable mean? It's a measure of the breakdown of a chemical or a chemical mixture by microorganisms, and there is a test standard specifically for that we use, so that's what we stick to try and keep that terminology, if you like, consistent with actual test standards. So we have the OECD 301B test as part of a wider ISO 15380 biohydraulics performance standard. And essentially it means that the substance will break down by more than 60% in a 28-day window if it were to be spilt in an open environment. You can also get inherently biodegradable products on the market, which you'll see are between 20 and 60%, and anything less than that is not classed as biodegradable. So for all the products in our Shell Panolin range, they are all classed as readily biodegradable products. Do the biodegradable lubricants have different specifications? Yes, so as I just touched on, they have their own ISO 15380 performance standards. So they are up there, they're regulated. You also get eco labels. So when something is readily biodegradable, has low ecotoxicity and is non-bioaccumulative, then it is classed as an environmentally acceptable lubricant, or an EAL. So you'll see that in the portfolio too. But essentially that EAL means that it will have some kind of eco-label or accreditation to it. There are multiple of those, for example, like the VGP, which is for marine vessels, which is for any marine vessels in the UK, we'll focus on that. That would be chartered into US waters, for example, then it would require an EAL eco-label. And then some equipment manufacturers also have tailored specifications like the likes of Bosch Rexroth. And I'm going to hand over to Tony now, who will talk more around the different base stock types that you get for biodegradables, just so you get an idea of the fact that not all biodegradables are equal, and there can be a strong variance in terms of performance, and it is all a bit of a balancing act between performance and then the environmental eco-label side of things.
Okay, thank you, Victoria. I mean, I think obviously you've a lot of experience in the room here today, and I think one of the confusing elements in the market, certainly since I was first dealing with biodegradables back in 19 years ago, but I think the first use of them initiated in about 1998. And I think most people think all biodegradable lubricants are the same. They're not. Clearly, within the market now, you'll find these distinct 4 types of bio classifications. And I'm not sure if you're familiar with the acronym. So if you are, forgive me, I'll just explain it. So HETG just simply means hydraulic environmental triglycerides. These are vegetable oil based, rapeseed oils. Now, these were probably the first biodegradable lubricants to be used in the industry, in the forestry industry. So as a chain bar lubricant, it's flung off into the environment and it has very good biodegradability characteristics. However, that type of fluid, it's low cost, but when you subject that type of fluid to elevated temperatures, it can lead to lacquering and deposits within the system. And what happened, and where all the myth and rumour comes from originally, is that somebody put that type of fluid in a hydraulic system and they had issues. So that's where the myth and rumour started. But as I said, not all biodegradable lubricants are the same. So we move down the scale, and I'll leave the HEES to last for a reason. So we've got HEPG, hydraulic environmental polyglycols. Now, these are PAGs, as they're generally known. They're very good lubricants. They have specific applications, but the big issue around them and why they haven't been widely adopted in the market is compatibility. So incompatibility with certain paint materials and sealing materials. And if you're looking to convert a system, it's not an easy process. So they're not the most widely adopted in the market. Then we come into the HEPR, which is hydraulic environmental PAOs and related products. Now, these are PAO-based products. They appeared in the market, say about 10 years ago, but were described as inherently biodegradable. So didn't meet all the criteria of OECD 301B. However, they're very good lubricants. The biodegradable lubricants tended to be in the thinner viscosities, so they would probably have to add some friction modifiers, and then you can get into some shear stability issues later on. But I think what we are seeing is that these products are starting to make an increasing presence on the market, because they're now able to add some renewable content to make the full claim for readily biodegradable under OECD 301B. So you'll probably see that type of product appearing in the market a bit more these days. And then we come back to the second in the slide, which is the HEES, hydraulic environmental ester synthetics. Now, this is the product classification that the Shell Panolin and the Panolin products were based around. So these are saturated and unsaturated esters. Within that group, and the biggest confusion that I found within the market, because if you looked at a technical data sheet with 2 types of product that were on the market at the time, both would have HEES. But one could be unsaturated ester and one could be fully saturated ester. And the difference between them is in their performance characteristics. And the reason for that is in their molecular structure. So in the unsaturated base products, base fluids, there's a double bond within the molecule when subject to oxygen will oxidize, and that can lead to lacquering and sludge deposits at certain elevated temperatures. They're good high-performing products, and we have them in the range because unsaturated tend to lend themselves to have better fire-resistant properties. Then we look at the fully saturated esters. They don't have the double bond in the molecule, and therefore they have really excellent oxidation stability, which gives the customer or the end user the benefit of potentially to extend the oil drain periods, which makes them very cost effective in use because initially they are more expensive than conventional fluids. So that's the fundamental difference in them. And then even within this HEES classification, and if you just look at the saturated ester element, there are many and various chemical base fluids. So the chemist can actually design the ester function of the fluid. So if you want a fluid that has better oxidation stability, you can design the molecules to do that. And I think the big, and you see on the right hand side there, the big myth around ester-based fluids is hydrolysis, because it's the reverse process when they formulate them. So essentially it would revert the fluid. So with water and high temperature, you can revert the fluids back to acid and alcohol, because that's what it's a reaction between acid and alcohol. However, in practice, and again, think what I just said, the chemist can actually design the molecules to resist hydrolysis. So they can build the ester function in the middle of the molecules, build it around it so that the water can't get in there. And in practice, we don't see it happening. Even in stern tube applications where you have potentially high water ingress and temperatures, it just doesn't happen. You can make it happen. I mean, anything, you can break anything down, but you would need significant levels of water, and you'd need high temperatures above 150 degrees and a catalyst to drive it. So another myth busted that, yeah, if you add water, you can hydrolyze the fluids, but it doesn't happen in reality. And I think, as Victoria said here, within the industry, so within the range, you have products that are determined as EAL. So any product has EAL in the name, they are readily biodegradable, with low ecotoxicity and non-bioaccumulative, which means, you know, there's not an accumulation of toxic materials in the microorganisms that actually digest the fluid when it's spilt into the environment.
Yeah, thanks, Tony. So yeah, I mean, to kind of wrap up that, this is the key takeaways that I would love for you to kind of remember from all of that is essentially, I mean, our products that we're using are synthetic esters. That is what's commonly used in the market the most. Specifically, saturated synthetic esters are offering the really high performance that we can see. And also the fact that you can have biodegradable products, like our top one that I will show you, the S4HLP synth, but also EALs, and they have their place too, as do unsaturated esters as well. So we'll have a look into the portfolio as well now in a second, but I just wanted to preface this too for those who may not know. So Panolin itself was a brand, and Shell acquired Panolin in 2022 and rebranded that and did the full launch of the new product range of Shell Panolin. So a lot of the same formulations, but just a change of branding there. And Panolin itself has been going for 40 plus years and was market leader in the industry of biodegradable lubricants. So they're not necessarily new products to the market, they have been around a while. And Shell Panolin is now the rebrand and the full force of Shell to hopefully expand its place in the market. So in the portfolio, as you can see here, there's a whole range of hydraulics, gears, greases, stern tube oil, turbine, wire rope, transmission fluids, and even some specialist fluids as well, like vapor phase corrosion. And they will have different tiers. So when we look at like hydraulics specifically, you'll see, as I mentioned, we have the EAL range. So those that need some kind of an eco label, whether it be VGP compliant, as I said, for marine, or whether it's the EU Eco label, or you can get things like the Swedish standard specifically for Sweden. And then you have the readily biodegradable and low ecotoxic range. So on the right there, you'll see the Shell Panolin S4 HLP synth, which has a Bosch Rexroth fluid rating as well. That is our kind of shining star. That's what most of our portfolio is. That's actually bought by customers, is that product, and it's got a lot of great examples and use in practice, and really sees that long life, which lends itself then to the total cost of ownership benefits. And then you have the kind of middle tier ones, so the S3, which is a blend of saturated and unsaturated esters, and then you get the unsaturated ester-based products that are on the bottom there. And as we said, they have their place too. They have good fire-resistant properties, and that can be very useful in applications, particularly like tunnel boring, for example. Similarly with gears, again, this is just to kind of show you there's a whole range out there, so I won't go through everything with you today, but I think hydraulics is one of the main ones that you'll probably focus on. And then, did you want to go through this one?
Well, yeah, I mean, it's just a way of demonstrating the oxidation stability performance characteristics of the S4, Shell Panolin S4 saturated ester base fluid. So there's an industry test method, the ASTM D943 modified test. So this is a test with no water, because if you think back what I just said, if you add water to this fluid, it can hydrolyze, and this particular laboratory test will have elevated temperatures, and it's designed just to have a measure of the fluid's ability to resist oxidation. So they heat it up to, I think it's 90 to 120 degrees, and they measure the time it takes to reach 2 KOH, that's potassium. So it's a level of potassium hydroxide they use to neutralize the sample. So they measure the time. There is an industry standard of 1,000 hours, and that fluid achieves 6,000 hours. Now, what does that mean in practical terms for the operators? So it means potentially they can extend the oil drain periods, which makes the fluids cost effective, cuts down on logistics and man hours under machines where the draining previously would be draining the oils. So that's been a big benefit, and we have lots of experience in the field and examples where that actually occurs. I can actually give you one example, so which is the London Eye. Not many people realise that it works with hydraulics, and in the year 2000 they filled it with S4 HLP synth because it sat over the River Thames. They had to fill it with biodegradable lubricants. They didn't particularly want to because they had no experience with it. So they filled it. We monitored it regularly all the way through its life, and it went to the year 2012 ahead of the Olympics before they actually changed the oil. It did, in all the systems combined, 92,000 hours of operation. We tested the fluid because it was a really interesting study, because it's a nice, I think it's about 2,000 litres, 50 degrees temperature. So it's genuinely aged fluid. So we put it through all the tests and it still met all the criteria. So that's a genuine example of what it can achieve. Admittedly, it's not the most arduous operation, but we have upper applications such in the rail industry, which are hard-working machines, higher temperatures, and we see the same thing there. We see extended oil drain periods.
Yeah, so I mean, in accordance with that, also outstanding equipment protection, so a high viscosity index, so it can perform well under a range of temperatures. In terms of pressure, speed and loading, designed to provide things like shear stability and wear protection and anti-scuffing properties. And then also at the bottom there, as I kind of touched on, we've got the Bosch Rexroth approved biodegradable hydraulic oil. I believe we were the first in the market to get that. And then, as Tony's also touched on, as you can see from the dry toss life of 6,000 hours, particularly of our main product, you get the extended oil life. So that can really benefit customers from a total cost of ownership benefit for things like, as you say, reduced downtime, less man hours, less waste removal costs. We've seen some really niche applications with like health and safety in terms of high cost to get to very difficult to reach areas. So if we can reduce that by reducing the number of times they have to go and perform that oil drain, that's also been a cost saving very dependent to the customer itself. But yeah, as I also touched on, we've got a lot of industry expertise and a lot of examples, and we can maybe talk to you about them more afterwards as well. And now we're in Shell, we've got the services associated with them as well, in terms of Lube Match to help decipher which products you might need, and Lube Analyst as well in terms of oil condition monitoring, which can support to know those kind of the longevity benefits, you can see them. And then seal compatibilities, do you want to just touch on this one as well?
Yeah, because this is a subject, again, that raises lots of questions. I think it's the topic that we get the most questions on. And it depends which sector we're talking about, particularly in the marine and offshore sector, it's quite relevant. So if we just look at the slide there, with the ester-based products, it's FKM, FPM, Viton type sealed materials. That's the preferred option. Now that doesn't mean, because there is a myth that the esters are not compatible with MBRs and certain other materials. I can tell you that PVC and EPDM, forget it because it's not suitable with esters. But so the guidance we give, FKM, Viton is the preferred option. In terms of MBR seals, what we state is that come back to us. So we may have already tested certain materials, and if we have the data, we can actually give you guidance on that. If we don't have it, and what is different today than 20 years ago is that the seal manufacturers have good knowledge of the ester-based products now, not just ours, but everybody's. So they're able to give very good advice, which materials suit which options. If none of that's available, then we've got no data. The seal material, we can then actually request testing of a specific seal. But the general advice, and my experience, so I'm going to say my experience of it, if it's MBR of good quality branded product of a shore hardness above 60, we don't tend to have any issues. So but it's a vague statement because there are so many variations and qualities of MBR in the market. So particularly in offshore, because they're working in different regions of the world and they may be buying certain materials in certain countries that are not quite as they require them. And so, yeah, that's the guidance around it. So if there's any specific questions, you can come back to us. If we have the data, we can give it to you. The manufacturers, because again, the seal materials are complex formulations of elastomers and such like. So matching the correct polarity of the fluids, because some fluids can shrink the materials. Esters tend to swell the seals slightly. So you need to find a balance in polarity between the seal material and the base fluids to make sure you've got the correct match. But I'll tell you, I think the market has more experience around that space now. But that's the biggest topic that we get questions on.
Okay. And I just wanted to put this on here to kind of show you the depth and breadth of the kind of different standards and approvals and legislation that there is globally. As you can see, there are some that are impacting the UK, but I think specifically like UK legislation, I don't think there is anything, but we do see the crossover of these other ones requiring maybe eco labels in certain applications or sectors. But essentially this is for us to worry about. This is for us to worry about the balance in our own formulations of performance alongside these requirements when needed. And also for you guys just to see there are already a lot of them, and so who knows what might happen in the future, if any of these might expand in terms of regions or might be new ones that come into play. So yeah, just wanted to give you a bit of an overview of what there is at the moment globally. And then in terms of sustainability, I mean, obviously the product itself is a biodegradability, so that's a big aspect of it in terms of environmental for customers. But a couple of examples, we like to avoid emissions, I mean by reducing emissions during the production with solar energy at the lubricant plants, or reducing emissions, for example, potentially with your longer oil drain intervals, it's less oil being purchased and therefore less waste oil being disposed of. And then also carbon compensation via nature-based solutions as well to compensate emissions. So we'll have a look now at where biodegradable lubricants are used, the primary sectors and typical applications, but they are used in multiple regions across the globe, they are used in multiple sectors across the globe, and even within those sectors, lots of different applications. But generally, they are used in sensitive environments where a leak might cause harm to the environment. And that tends to be near waterways or agricultural land, or even in urban areas where, you know, there might be people near or houses near, and so we want that spill to kind of be as minimally impactful as possible in terms of on the environment. And the biggest demand for biodegradable lubricants is coming from the sectors of construction and mining, from marine and offshore, from forestry and agriculture, and also power generation generally in the services that go around the wind turbines in terms of creating the projects. But yeah, lots of different individual applications, as I mentioned earlier, tunnel boring, but also in ports or ditch cleaning equipments or big excavators or big dumper trucks, in docks and locks and oil platforms, in forestry, agriculture. I will caveat chainsaws, we actually don't have a chainsaw application in our portfolio, but yeah, also harvesting machines. So big demand, big wide range of customers that these products could be used on. One that's also not on here is rail, which, as Tony also mentioned, we've done very well with in the UK in the rail industry. I won't go into too much detail on all of these because I've got a few to show you, but I just wanted to show you the kind of different application points that you can have in the machines, and in theory the number of different ways you can get biodegradable lubricants in there if a customer wanted to be, you know, totally using biodegradable lubricants. So yeah, I mean, that's obviously an example for construction, but we also have them for forestry and marine and offshore marine construction as well. So yeah, I mean, that kind of concludes what we were going to speak about in our lecture for today, but I would love for any questions to come after. But yeah, thank you very much, and I hope that you've learnt something and we've managed to myth bust some of the things that we spoke about, or help you understand more awareness about biodegradables and why the price premium might not need to be such a turn down, because there are the total cost of ownership benefits associated with them. So yeah, thank you.